Now in this video lecture, I will discuss the very important property of colloidal solution, that is your coagulation or precipitation. I hope you know what is the meaning of coagulation. Coagulation means to coagulate, means जिसको आप हिंदी में कहते हो जम जाना, बैठ जाना, शटल कर जाना. Actually we know that the colloidal particles, we know that the colloidal particles are charged particle, either they are your negatively charged or they are your positively charged. Now, due to the presence of similar type of charges on colloidal particle, they always mutually repel each other, and due to this repulsion, the colloidal particle will remain in the colloidal form. For example, if one particle have a size of 10 nanometer, again another particle have a size of 10 nanometer, and again the third particle have a size of 10 nanometer. So, till they will not form any aggregate, they will not settle down and form precipitate. However, if we are able to remove this charge, if we are able to neutralize the charge present on colloidal particle, suppose if we neutralize, then what happens? Their charge will vanish, and when there is no charge on colloidal particle, they will settle down and form an aggregate, and it will coagulate or precipitate. So we can define coagulation. We can define coagulation as follows. Coagulation is defined as the settling down of colloidal particle. Coagulation is defined as the settling down of colloidal particles. Now, this coagulation is also known as your precipitation of colloid. Now, this coagulation can be done by different method. For example, different ways in which we can coagulate a colloidal solution. The first is, just we have studied, the first is your electrophoresis. भाई आपने electrophoresis में देखा कि let us suppose this is your YouTube, and in this YouTube we have, suppose this is our positively charged plate and this is your negatively charged plate. Now, if we put a particular colloidal solution, and suppose this colloidal solution is your positively charged, this is your positively charged. So obviously what happen? क्या होगा भाई? चूंकि ये colloidal particle आपका positively charged है, इसलिए ये जो colloidal particle हैं, they will collect near your negatively charged plate. So as they collect near negatively charged plate, they form your aggregate, means they will leave the dispersion medium. यहां कलेक्ट होने का मतलब है कि ये डिस्पर्सन मीडियम को छोड़ करके यहां निगेटिवली चार्ज प्लेट के पास जमा हो गए, और जब ये जमा हो जाएंगे दे विल फॉर्म योर प्रेसिपिटेट, और वी कैन से कि द प्रोसेस ऑफ कोagulation हमारा हो गया. नाउ व्हाट इज द सेकेंड मेथड? द सेकेंड मेथड इज योर बाय बॉइलिंग. The second method is your by boiling. For example, you can just consider your milk is a colloid. Milk is a colloid. Milk आपका colloid है. आप दूध ले लीजिए, इसको बॉइल करिए. So what happens in milk? We have your fat droplet. We have your fat droplet, that is your colloidal particle. Now what is your dispersion medium? Dispersion medium is your water. तो जब आप इस मिल्क को बॉयल करोगे, जब आप इसको मिल्क को बॉयल करोगे, then what will happen? The dispersion medium जो कि आपका वाटर था, it get evaporated. वो evaporate कर जाएगा, and after evaporation the leftover material is your only fat droplet, that is your colloidal particle, which will coagulate or which will your settle down or which will form a precipitate. So this is also one of the example that we can carry out precipitation, or you can say coagulation. Third is your The third is your by persistent dialysis. So by using dialysis we can also coagulate colloidal particle. Actually dialysis is a process in which we can separate colloidal particle. So when the colloidal particle will separate out, it will form a aggregate or it will form an precipitate. The very important method of coagulation, that is your by using suitable quantity of electrolyte. By using suitable quantity of electrolyte. For example, suppose your colloidal particle is positively charged. मान लीजिए कि आपका जो colloidal particle है वो positively charged है. Now we add suitable electrolyte which contain active ion of opposite charge, which contain active ion of opposite charge. So since it is your positively charged, so the active ion of opposite charge is your negative charge. तो इसका जो आप इलेक्ट्रोलाइट जब ऐड करोगे इसमें, तो उस इलेक्ट्रोलाइट का निगेटिव आयन क्या करेगा, ये इसको एब्जॉर्ब कर लेगा, and then what will happen? They will neutralize the positive charge of the colloid. ये जो आप इलेक्ट्रोलाइट ऐड कर रहे हो, which contain active ion of negative charge, वो क्या करेगा, इस पॉजिटिव चार्ज को न्यूट्रलाइज कर देगा, and when it will neutralize its positive charge, then the colloidal particle will form aggregate and it will coagulate. The same is applicable for your negatively charged colloid. For example, if your colloid is negatively charged, आपका colloidal particle negatively charged है, then you add an electrolyte which has an active ion of positive charge. Then this positive charge, what it will do? It will neutralize the charge present on the colloidal particle and your colloid will coagulate. Now, in this regard, there is a very important rule. In this regard, there is a very important rule, and the rule is your Hardy-Sulz rule. SCHULZE. Hardy-Sulz rule. What is this your Hardy-Sulz rule? So write this rule. According to this rule, greater is the valence of the active ion, greater will be the coagulating power. Greater will be the coagulating power or fluctuating power. Greater will be the coagulating power or fluctuating power. सवाल उठता है, what does it mean? For example, suppose we have to coagulate a positively charged salt. तो भाई देखिए, आपको पॉजिटिवली चार्ज सॉल्ट को कोगुलेट करना है, इसका मतलब आपका जो एक्टिव आयन होगा, दैट एक्टिव आयन इट मस्ट बी योर नेगेटिवली चार्ज, क्योंकि एक्टिव आयन जो इसको कोगुलेट करने जा रहा है उसके पास उल्टा चार्ज होना चाहिए. सो व्हाट विल हैपन इफ वी हैव एन आयन लाइक FeCN6 4-. If we have anion like your phosphate ion, if we have anion like sulfate ion, and if we have anion like chloride ion, तो पॉजिटिवली चार्ज सॉल्ट को कोगुलेट ये भी कर सकते हैं क्योंकि ये निगेटिव चार्ज है, ये भी कर सकते हैं क्योंकि ये निगेटिव चार्ज है, ये भी कर सकते हैं क्योंकि ये निगेटिव चार्ज है, और ये भी कर सकते हैं क्योंकि ये निगेटिव चार्ज है. बट द क्वेश्चन इज व्हिच आयन हैव ग्रेटर फ्लक्चुएटिंग पावर? द आंसर इज योर फेरोसाइनाइड आयन. देन वी हैव फॉस्फेट, देन वी हैव सल्फेट, एंड देन वी हैव क्लोराइड. इसका मतलब ये हुआ कि अगर किसी पॉजिटिवली चार्ज सॉल्ट को कोगुलेट करना है तो सबसे बेस्ट होगा ऐड करना फेरोसाइनाइड आयन, देन फॉस्फेट आयन, देन सल्फेट आयन, एंड सबसे कम कोगुलेटिंग पावर किसका होगा? तो क्लोराइड आयन का. सिमिलरली for the coagulation of negatively charged salt, अगर negatively charged salt को coagulate करना है, then we can say aluminium ion 3+ maximum, then we have say barium ion or magnesium ion, and then we have sodium ion. तो अब आप देखिए यहां पर negatively charged salt को you have to coagulate, so the active ion should have positive charge. So this aluminium ion have maximum coagulating power, and then we have barium ion, and then we have sodium ion. So this rule is known as your Hardy-Sulz rule. It is very important for examination point of view. I hope you must have understand this property. So thank you.